Hi everyone, I'm Tao Lon, currently a first year PhD student at Columbia University studying computer science. Today I'm going to present our work on tutorial hooks, generative AI tools to motivate science on social media. And this amazing work is done with all my amazing colleagues at Columbia University and Barnard College in New York City. And yay! So for this work, our main research question is what makes a good science communication on social media, and whether we could apply the emerging technology like large language models to help with the science communication process. So, science communication. From the old times to today, science communication has been an important thing for the public to understand and engage in a rapidly changing world. However, the communication process between the experts and the audience is sometimes really troublesome and complicated. For the audience, reading formal language in an academic publication that has a lot of jargons in it will easily turn them off. How boring. For the writers, if they want to write something really engaging and relatable to the lay audience, it's actually really hard for them to brainstorm and start writing. This is described as mentally demanding, which means that the writing process usually requires a high cognitive load. Writer Flowers and Hayes' works on cognitive process theory of writings in the 80s. Thus, instead of reading all these boring journals and publications that we wrote, more and more lay audience start using social media platforms to learn about the world, like Instagram, TikTok, Twitter. The science materials on these platforms are usually more interesting, engaging, and personal. The narrative-driven communication can easily motivate the lay audience to keep reading and learning about the science materials. So we can see the huge phenomenon nowadays, which is called tutorials. Tutorial is an emerging format for explaining complex STEM topics on Twitter. As you can see from the image on the right, there are usually multiple threads of tweets in a tutorial, sometimes 8 to 10 of them trying to explain one major question mentioned in the first tweet. For example, this tweet shows what makes your fingers winkly during the shower. So the author put the question on their first tweet and then answered them afterward. Today, we're gonna focus on the first tweet, which we call them hooks. As the previous study indicates, the first tweet hooks the readers with a personal story and an intriguing question. So it usually gives many relatable materials and also drives people's curiosity to keep reading them. But how can we know what is exactly a good tweet? Are there any rubrics for it? The answer is no. So, welcome to our tutorial 101, how to write a good tutorial hook. Chapter 1, what makes a good hook? Let's look from a few examples. Firstly, from the winkly finger example that we saw earlier, it first starts with a question. Why do my fingers get all winkly when I take a bath? This was a question that my 3-year-old daughter asked me recently after bath time. I thought for a minute, then realized I don't have a clue. The explanation is so much cooler than I expected. Then it goes to the following tweets. Then the second example is talking about California wildfires. The author says, I have been watching the landscape of my childhood burn with an aching heart, and wondering how much climate change is to blame. Turns out, human activity is a major driver of California's wildfires, but not just in the ways that you might imagine. Then goes with the wildfires photograph. From these two examples, when we quickly read through it, we could easily find no jargons. Every examples are really interesting and easy to read and understand, even if you don't have any background knowledge in the field like biology or environmental science. And secondly, they usually give us an example that people may have experience with in their daily life. Like the one I marked in yellow, there are winkly fingers, your kid asking you a question, or watching some burning landscape during wildfires. They just include visuals, stories, examples, and anecdotes. Also, the last sentence of the hook usually leaves out some unanswered questions, thus making the readers feel curious and keep reading on the threads. Thus, after we collect all these patterns that we find from a large set of tutorial hooks, our team generalized them into three major requirements for good and engaging tutorial hooks. The first one, as we said, is jargon free. The hook should include no jargons, so the public won't have huge barriers to keep reading and understanding the materials. Thus, the readers could easily engage in the contents. The second requirement is to include a relatable and specific example. This is really important as the lead in, so people could easily know what question the author is trying to ask and find common ground easily. Then, the public will find it engaging and relatable, so keep reading. The final requirement is to include an intriguing question so it keeps sparks curiosity and draw them to the following threads. STEM experts also wanted to write one, but it's still pretty hard for them to write. The reason for that is that their training on the writing process are majorly serving for the traditionally science writing materials, like communicating to other experts in the field instead of the public. So they have a lot of questions. How to avoid jargons, how to get a specific and relatable examples that is contextualized enough to the general audience, and how to even come up with an interesting question is pretty hard to them. So it's really complex and cognitively demanding to write something engaging. So here are the challenges that we want to solve, and how can we help? Let's introducing GPT. Current improvements in these large language models are showing huge potentials in helping with the science communication due to their domain knowledge and contextual understanding capabilities. They can write pretty well, largely support many cognitive tasks. So, welcome to our next chapter in our class, how to use large language models to co-create hooks. We first conduct a prompt engineering study using GPT-3. Today, we will just gonna briefly talk about the findings that we find, and for more details, please refer to our paper. So the first thing that we find to do with GPT, we try to find what are some good prompting strategy to write a good hook. We try to include a few example hooks as trainings, as well as the rubric inside the prompt. However, we find that GPT cannot directly write a good hook. They don't know whether a contextualized example is good or not. They sometimes give examples that are too broad or too unrelated or even not true. And the hooks they wrote usually don't satisfy our rubric. Thus, our first result that we find is GPT cannot directly generate a good hook on their own. So it needs human input and draws to the need of building a co-creation system. Secondly, after playing with GPT more and using the method of scaffolding complex tasks into tangible steps, we find that GPT could actually generate much more better common experience and hooks. Then we could help build the interactive system using the training of the task and prompts. So here is the fundamental interface of our interactive system. We just implemented the most basic feature and designed to test its functionality in our usability testing session. We will release a higher fidelity prototype after this and open source it to the public. So our system includes a total of 6 steps. The first step is to help users generate everyday examples of an abstract topic. So when the writers input a science topic, let's say VPN here, they will show up 5 basic everyday examples that people may know about VPN, like connecting to work office server or accessing a public Wi-Fi. Then among these 5 results, the users could pick the everyday example they find most interesting and relatable to go with it to the next step. Also, if they don't like the 5 examples generated by GPT, they can always regenerate or make edits to them and go forward. Then the second step is to generate common experience based on the everyday example they chose. Based on the everyday example of VPN, the systems help generate 5 common experience people may share in their daily life. So some experience are like getting unauthorized access to computers or phishing attempts. Similarly, users could always regenerate, make edits, or use them directly for the next step. Then the third step is to generate a personal anecdote about this common experience. As we could see many personal anecdotes from the previous hook examples, we ask users to input their chosen common experience into the system to generate an anecdote. Then the fourth step is to make this anecdote more specific by adding more contextualized details. For example, if your anecdote is about your emailing experience, then this step could make it more contextualized and detailed, like when you are sending emails to your colleague or your friend or your professor, so makes the final hooks be more specific. After that, the fifth step is to generate an example hooks by training all the previous results in a prompt. Then the system will generate a hook for the users to make final edits on. Then the sixth step is just a text box where the users can write their final hooks in. After building the system, we want to test the usability and the performance of it. We invited 10 users to try the system. Each of them takes around 1.5 hours to finish the study. They first got an introduction about a task in the system, then they got to write 6 hooks on 6 science topics. And for these topics, 3 of them are using the system and 3 without. And they each need to fill out a NASA task load form after each writing task to know about their experience in writing in each condition. Finally, after the 6 hook writing task, we conducted a 20-minute semi-structured interview. For the first result, we found that LLMs largely ease the hook writing process, which is traditionally considered as complicated and mentally demanding. As you can see from the graphs on the right, the bars in green show the with system condition, whilst the blue bars show the without system condition. From this, we can see that in the with system condition, users usually experience much less mental demand and efforts. At the same time, using the system can help the users perform better and have less frustrations. After doing the statistical analysis, we found that all these four categories are statistically significant. For today, I will just quickly go over a few findings that we found for the mentally demanding section. So the users mentioned that during the with system condition, the system could easily turn the language into digestible terms that people can easily understand. However, during the without system condition, it's actually pretty hard for them to find a concrete and specific example of an abstract topic. With the system, people could easily explore a variety of examples and common experience people may have. The process of simplifying languages and finding examples is largely supported by the system. Below are two examples that our users wrote for the topic of cybercrime. We could just read the first sentence leading. The left column is a user writing without a system. They say, these days computers are just a huge part of our lives. What illegal activities could be going on within our computers? But the right column, the with system condition, actually gives a more relatable experience. Like, have you ever received a call out of the blue from someone claiming to be from your bank, asking you for your personal information? So much more details, right, with the system. We included more examples in our paper as well. Please read them. Then the second result we found in the user study is that users actually make a lot of edits throughout the interactions. Similar to the reason why we design a co-creation system, these interactions need human inputs and evaluations. Thus, we also wanted to see when and why people started making edits. Then we find two patterns. The first one is users' edits for the three hook requirements, jargon-free, specific examples, and intriguing questions. And the second one is more interesting. It's users edit for personal styles. Users are making edits to the LLM generated hooks to make them fit more according to their own writing styles and their favorite hook examples. Throughout the process of making edits to their words, tones, and even design layouts of the tweet, for example, people will change the words like "Do you know what?" to "Have you ever heard?" or delete the words like "exactly" to or split long questions and sentences. They say that in addition to being the writer of the content, they also got a chance to become the first reader of it. After the whole editing and co-creation process, they find more connected and a sense of ownership to their hooks. You can find a more extended discussion in our paper. Finally, conclusions. Yeah, we made it. Large language models can help the process of contextualizing science so people could easily find the writing engaging. Also, in a tutorial, the story and a narrative-driven approach really helps, while there needs a co-creation system for both system and users' inputs. Lastly, and most importantly, large language models are far from perfect. There are a lot of limitations in it. They are trained on a large amount of text available on the internet, which are built up towards bias against minorities who are not frequently online. And it also comes to the ownership issues of the writing when people are talking about. Thus, we are also looking forward to explore more in how to better mitigate these biases and the ownership issues by adding more parameters or designs to our system to help with it. Thank you so much for your time and listening. Please let me know if you have any questions. You can find my email address and the paper QR code here. Thank you.